All right, guys, welcome to another episode of CUDA Education. We are continuing on our investigation of the command buffer. Um, it's one specific topic that I wanted to address in this video, and I will proceed to doing that. But before I do that, just want to remind everyone, if you want to have all these Vulkan examples on your machine running, you could get tutorial number 1 and tutorial number 13. Tutorial number 1 is installing the Vulkan SDK. Tutorial number 13 is installing these examples, all of these examples here that you see. Now, this assumes that you have a Windows-based computer with a Vulkan-capable GPU. If you want to install if you want to be able to run the ray tracing examples, you're going to have a ray tracing capable GPU. For NVIDIA, that's RTX series. I don't know about the other GPU vendors, AMD and Intel and whoever else is out there. Okay, I only know about NVIDIA's GPUs. Okay, so if you want to be able to run these examples here, you're gonna have to have make sure your GPU is ray tracing capable. To run any of the examples, you have to make sure your GPU is Vulkan capable. So there's Vulkan, and then there's Vulkan ray tracing, right? So that's that. All right, so we're continuing our investigation of the build command buffers segment of the code. We're in the 700s. The code is about 910 lines long. Okay, so we're here, right? And we're just doing a blind sort of walk through all of the intricacies of this code. Now, if you guys remember what this code does, it creates a triangle that is ray tracing based, right? So rays are being shot, and everything here is rays that missed, and then everything here is rays that hit, and we have it in the form of a triangle, right? That's the geometry. We have our top level acceleration structure, a bottom level acceleration structure. The bottom level acceleration structure is the geometry, so in this case it's a triangle, and the top level is the instance, which is generally just one instance of a triangle. Okay, and we've kind of discussed that in previous videos. Okay, so of course you have to do a command buffer, which basically is the instructions to actually do commands and everything. We've kind of gone through these guys here, but what this video is about is about the vkCmdTraceRaysKHR. Okay, so the point of this lowercase vkCmdTraceRaysKHR is initialize a ray tracing dispatch. So we're actually now initializing the process of ray tracing, all of that stuff. We have our raygen shader binding table entry, we have our miss shader binding table entry, and we have our hit shader binding table entry. We've kind of already gone through those aspects, but what was interesting to me and what I took some time to really try and play around with is this callable shader binding table entry, right? And sort of what is this callable thing? This parameter is not optional. It is a mandatory piece of the vkCmdTraceRaysKHR call. And the official word on that parameter is it's a VK strided device address region KHR that holds the shader binding table data for callable shader stage, for the callable shader stage, right? So what I've sort of understood this to be is if you want to do additional processing, if you want to do special processing, if you hit a certain object or hit at a certain part or region of your scene, and you want to, do special processing or call additional shaders, this is where this callable shader binding table parameter comes in. It actually is pretty cool. If, for example, you have shadows and you want to do special processing with the shadows, right? Or, make an object transparent or some other thing. Outside of the regen instructions, the miss instructions, and the hidden instructions, you could call additional shaders to do specific stuff. All right? It's not an optional parameter. It is mandatory. In this case, I believe in this code, it's pretty like, it's inputted, but it's not really doing anything. It's just kind of a dummy entry, right? But it has to be, it has to be a part of this vkCmdTraceRaysKHR. All right. So here it doesn't do anything. We have our width, height, and depth, which, I would play around with it, but it basically just squishes the triangle. Like if you change the width to a smaller value, it just kind of basically squishes the triangle into, maybe a left-hand column or everything. The whole scene is squished. It's not anything of a big deal. I assume the height does the same thing. But this color shader SBT entry thing is actually pretty powerful, right? So as I said, in our triangle example, it doesn't do anything, right? It's we have our miss, we have our hit, and of course we have our regen. And if we disable any of these, then you don't see one or the other or what have you. Okay. But I do want to expound on this callable shader binding table parameter. And what I want to do is basically, so one of the other examples, the ray tracing callable, actually, it actually uses this callable entry to do something that is simple. But remember now, we said that this callable entry is like special processing or additional processing, or based on contingencies or for contingencies or what have you. It might be you could use it for special stuff. So in the callable example, when we run the callable in the callable script, we have basically 3 triangles, 1, 2, 3, right? And we could rotate them upside down, everything as we normally did before, okay? But we have 3 triangles, but this callable parameter here, dictates sort of what's happening inside of each of the triangles. So here we have a checkerboard, here we have a solid color, and here we have stripes, okay? And this is all managed by this callable parameter, okay? So what happens is that we have callables on all of these triangles, right? And we have specific shaders that are called based on, the first, second, or third triangle, right? Whichever one it is. So these specific shaders changes the triangle. So we have the checkerboard, the solid color, and the stripe. Okay. So that's what this callable parameter can do. All right. So let us dive into the callable. Let's go into the source code. Okay. So here we have ray tracing callable. So we have callable 1, we have callable 2, and callable 3, right? let me just, I did this. So we have our shader groups, right? We have ray gen, miss, hit, but then we also have a shader binding table that's callable. Okay, so that's an additional thing that we didn't have in our ray tracing basic, right? That's just a destructor. Okay, the bottom level acceleration structure for this sample contains 3 separate triangle geometries, so we can use geometry index ext and the closest hit shader to select different callable shaders. Okay, so we'll leave that alone for now. Okay, we have callable 0, callable 1, and callable 2. This is for the top level acceleration structure. So notice that we have additional things here. No, I think the top level acceleration. The top level acceleration structure, right? Object instances, right? So it's not part of. I'm sorry. This is part of the the shader binding table, right? So, right, create shader binding tables. Okay, so the callable shader binding table contains one shader handle per ray traced object. Right, so we have 3 triangles. So we have a shader binding table for each one of them. All right, but I don't want to get bogged down in minutia quite right now. What I did want to get to though is this part, not this part. Right, is this part right here. So it's calling a shader binding table. It's calling an external shader. So callable 1, callable 2, and callable 3. And we could see it here. Callable 1, callable 2, and callable 3. So callable 1 is this. Generate a checkerboard pattern. Callable 2 is a solid color. Callable 3 is a line pattern. Okay? So notice that for the shader group stuff, we're doing a for loop. And we're basically, for each one of the triangles, we're loading a specific shader for it. Okay? So what basically happens is that we set it up to have an external callable, a callable shader, and then okay. And then when we run our vkCmdTraceRaysKHR, we have our callable parameter here, but it is associated with each one of the triangles, right? So we already saw that it generates 3 different patterns based on the callables here, okay? But let us kind of hack this thing. And instead of because we're going from 0 to, I guess, 2, instead of going from 0 to 2, we're just gonna make it all the callables basically associate with with callable 1, right? So callable 1 is a checkerboard pattern, right? So based on our logic, if we force all of the callables on each one of the triangles to be callable 1, then we should get all checkerboards. And that makes sense because callable 1 is a checkerboard pattern, right? So that's what this callable feature is on the parameter. I kind of don't want to get into the details of everything right now. I just really want to focus on this guy right here, right? I just want to focus on this guy, right? So we know that basically for each one of our objects, we could call an external shader to do extra processing, right? In our simple ray tracing basic, we're not doing anything with it. We just have it here and it's just there, and it's just a placeholder. It's not doing anything. But in this callable example, we're actually doing something. So let's continue on our journey. If we change this to, instead of it being 0, it'll be 1. So that means we're going to be doing callable 2 now, right? So if we do callable 2 was what? A solid color, right? And sure enough, all 3 triangles are a solid color, right? If we do callable 3 now, because it's 2 plus 1, we are going to get a line pattern, right? For all 3 of them, all right? So that's just the power of the callable parameter. Let's put it back to I, because we're looping over 0, 1, and 2. So let's put it back to I, and then when we run it, we get our 3 different fills for the triangles, right? And yeah. Don't ask me about when you rotated all this stuff. I don't know. But it's pretty cool. Pretty cool, right? So this callable parameter is just like extra processing, right? This vkCmdTraceRaysKHR is pretty important. Initialize our ray tracing dispatch. But just understand and appreciate, guys, there's a lot of setup before you could just get to this simple call, right? It's a lot of setup. Here we have a very simple dummy strided device address region KHR, but for the callable thing, but for the callable script, it's a whole different. Let me see. I want to see where this guy is. Copy. There's no strided here. Where is the strided? Okay, so I don't know. It's a different cup of tea here. But anyway, just know that for us to get to here, it's a whole different cup of tea. But notice that we have our shader groups, and we have one callable shader for each one of our objects. And we push back and all that good stuff, right? So that's what all this is. And that's pretty much the story of Callable. And that's really all I have for today, guys. Callable 1, 2, and 3. And then we have our other stuff. If we look at the ray tracing, the shaders, we have closest hit, miss, and raygen, right? So just like here, we have our closest hit, miss, and raygen. But notice that these guys have the 3 callables here, whereas this doesn't have anything, right? Because it was just a placeholder. So under callable. So that's pretty much it for this video. make sure to like and subscribe. Tell your friends. Remember, guys, tutorial number 1 and tutorial number 13. If you want to have these examples on your machine and be able to basically run this code and sort of work on it yourself, and also follow along with what we're doing here. But yeah, it's pretty cool stuff. You know, I'm not that intimidated about ray tracing anymore. I thought it would be way more complicated, but I'm slowly getting the gist of how all these things work and how they connect together. But yeah, this is where we do the ray tracing dispatch, right? Initialize a ray tracing dispatch, and we have to do a lot of work. You know, I would say I'm going to continue focusing on this stuff here. I'm not going to start messing with how we got to making all the callables and everything, because that'll be too overwhelming. Let's just finish off. I want to finish off this script and then move on to another script. I don't think I'll even necessarily move on to the callable script. There's like a whole bunch of other scripts here, right? But there you have it, guys. Get your friends together. Tell them about these videos. Tell them about Vulkan and computer graphics. For all of you creatively inclined people, all of you aspiring artists, all of you visual artists, graphic designers, UX designers, all that stuff. You know, you should appreciate this stuff, because it will come in handy for you, where you're actually putting pixels on the screen and all of that good stuff. Anyway, guys, thank you for watching. Have a great day.